start. What a bar. What a place to have the bar set. Okay. Anyone have any questions from homework? I had some really good questions during office hours. Does anyone else have any questions?
I had an interesting time with 66 from 6.1.
Okay, let's see.
It was having to find like the rate of annual compounding interest.
Good. All right. If you're asking me about 66, oh, wait. So this is not the one I'm thinking about. Okay. There's another problem later that's interesting. So this one about Kyoko?
Yes.
Okay. She's got $10,000. Her bank has several investment accounts, all compounding daily. Her goal is to have $15,000 by the time in 6 years. Oh, okay. So in this instance, we don't know the interest rate, but we do know what her goal amount is. So let's see. What would be easiest? Yeah. So what do we got? She's got 10,000. She wants 15,000 in 6 years. Okay. So we've got, maybe this is the right place. So here we go. We'll go up to here. Here's our good, here it is. It's the compounding daily, right?
Yeah, which is N, right?
Yeah, N will be 365. I don't think the book said 360 or anything strange. 15,000. We know T is 6. We know N is 365. And we don't know what R is. So do you understand? So they gave me A, they gave me T, they gave me N, they gave me P, and then I got to solve for R.
Yeah. That's what I got eventually. At first, I just set up the whole thing kind of wrong, and then I found the right compounding interest formula, and I reset up the whole thing. I just might have gotten lost in the order.
Oh, okay. So the exceptionally strange step is going to be taking the appropriate root to get rid of this power. I guess it's kind of strange. I don't know. Let me stop for a minute. So those of you who just came in, this is number 66. This is about Kyoko. She has a goal and she has an amount of time. And she wants to see, could there be an account with the rate that will get me there? I've got $10,000. In 6 years, I need to have $15,000. So I need like a 50% total yield over the time that it's in the account. So that's pretty good. So I got to solve this thing for R. And my claim is this is basically the same thing as solving this for X. Right? In fact, let me make it cubed. Why not? Same thing as solving that for X. Divide by 4, and then I take a cube root. Right? So what would I do first in this problem to start solving for R?
Divide the 10,000 from both sides.
Divide the 10,000. I like it. So now it's basically, what is this going to be? 1.5 equals this thing to this power, whatever that power is. I don't know. What is that power?
2,190. It's kind of gross.
What is it?
2,190. Yeah,
okay.
2,190.
Right. So here's the neat thing. I'm really curious now. All right, we know how to do this. We know how to do this. Do you remember what I had to put in my calculator to do like the 6th root of 11 or something? I had to put 11 to the
1/6.
I like it. So if I wanted to do the 2,190th root, it's actually going to be 1.5 to the 1 over 2190.
Okay.
And now let me see what the calculator does with that. I'm curious.
It gets something quite big.
Yeah, buddy. It's yummy. Then minus 1, and then times 365. And then you get something that's beautiful. It makes sense. I love it. So that's the weird step. That's the step we're not used to. But if only, I don't know. I don't think I had the time to rail against this symbol. I hate this symbol, this radical symbol. It should not exist because I already have a symbol that means what that does. And this symbol makes more sense. It makes sense. What are exponents based on? Multiplication. So what would it mean to have a 1/2 there? It means half of something multiplicatively. Isn't that what a square root does? Cuts things in half multiplicatively. So I kind of wish this symbol didn't exist. If that symbol didn't exist, then we would automatically know to do this, which is a little less mysterious. It's still kind of mysterious, but it's easy to know how to put it in the calculator, for example, right?
Does it matter which number you choose for n, as long as it's the same?
Well, no. The problem said daily, so it had to be 365.
Oh.
Cool. All right. I like it. Does anyone else have anything else? Because if not, I had another question from earlier that I wanted to address. Rio, which problem was it, Rio, that I was saying I'd do later?
That was number 51 and 54.
In this section? No.
Yeah.
Yeah? Okay. Oh, yeah. So this is cool. All right. So this sounds exceptionally weird. And I don't think the book shows you how to do this, but something that your graphing calculator can do.
There's only one brief area in the book where it says how to do it, but it doesn't give any examples.
Oh, that sounds great. All right, so let me show you this. I'm going to do it with a different set of numbers, so you guys have something to do. First, I got to wake my calculator up. Hold on. Poor little digital calculator. Here it comes someday. Come on, calculator. Come on. Okay. Let me show you this. So what's really, really cool is, and this is not that big of a deal. I just like to assign that because I like to remember to show you that your calculator is able to do this. If you go to stat right here, this is how I can edit. I can input data into my calculator. So let me get rid of some of this data here. I just need a couple of rows. All right, so if I feed this thing 0, so it goes to the point 0.5, let's say, and it also goes to the point 2, I don't know, 47. Okay. I don't know if that's going to make sense for this poor little thing. Let me think. Yeah, maybe. Okay. Now watch. I could do several things here. I could actually figure out, if I go to calculate, I can calculate a line that goes through those 2 points. Do you remember doing this problem in algebra? They gave you 2 points and you had to find the lines equation. If I tell it L1 and L2. So that's where my X stuff is in L1, my Y stuff is in L2, and then it can calculate there. The equation of the line would be 21x plus 5. There's the slope, there's the y-intercept. This R number tells me how good of a fit it is, and since there's only 2 points, it's a perfect fit for a line. All right, now that's not what the problem said, right? The problem wants an exponential. So what do? I go to calculate, and I don't stop at ln. I go down to exponential. L1, L2. So there's my exponential function that fits that data. 5 times this thing to the x power. So it kind of makes sense. I really want you guys to understand. And again, if you don't do this problem, I'm not gonna cry. I'm not gonna die. I'm not gonna do anything. It's just neat to know that your calculator can do this. What were the 2 points? 0, 5, and it was something insane. I can't remember the other point, but I got 2 points. So I could either have a line goes through those 2 points, but can't I also have an exponential function that goes through those 2 points? Couldn't I also have a radical function that goes through those 2 points, right? So that's why it's got all these options for how I want to try to fit the data. I can fit it with a linear equation. I can fit it with a quadratic, a cubic, a quartic, dude. I can do it with a natural log that we haven't even talked about yet. Exponential, there's a power function. Let's see, what would it do for a power function? Oh yeah, it doesn't like that. Okay, fine. Power functions are a little bit more needy. Okay.
Professor,
Yes.
my calculator doesn't say L1 or L2.
What kind of calculator do you have?
83.
Oh yeah. So if you hit stat, oh I see. When you hit edit, what does it say?
It says nothing.
Okay, do this for me. Hit stat,
Okay.
and do you see number 5?
Yeah.
Hit number 5, enter.
Oh, nice.
Oh yeah, you went back in. So if you go back in, now you should have all your list there, right?
Yeah.
Okay.
Okay.
And again, like I said, if you're not sure what just happened and you do every other problem, that's fine, right? That's not a critical thing. It's not going to be on the test or anything, but you just need to know that calculator can fit equations to given points. I like it. How many points do you think I would need for a quadratic fit?
At least 3.
Good. I need 3. At least 3. I mean, it could work with more, but I need 3 because there's A, B, and C that are unknowns. I like it. All right. So I only needed 2 here because the only things I don't know are A and the B to the X. I only know A and B. That's all I didn't know. So I only needed 2 points. All right. All right. So that was the one that came from office hours that I said I would do later so everybody could see it. Anything else from homework, guys?
Yeah, actually, I want to ask you more question about the 51. So L1 says L1, the input, the first input should be like 1. Like mine doesn't say 0. How can I change it?
Oh, go up. You already have numbers in there. Is that what you're saying?
Yeah.
So go up to L1, hit the up arrow so that it's highlighting L1, and then hit clear.
Can I hit clear?
Do you see clear?
Yeah. Then I type 0 in that.
And now you type 0 and yep. If you
Then
cleared it, huh?
it errors.
Sorry?
It errors. It doesn't. I can put the 0 in there.
Hold on. Oh no, did I closed my calculator. Why didn't I do that? Okay, so let's see.
See, first, like I can put only
Hold
1.
on. Okay, so right now your lists are empty, right?
Okay.
Right? Is this what it looks like?
Yeah.
All right, so when you hit the 0, do you see how I'm right here? I'm not up here.
Oh.
I'm right here. Yeah, yeah, no?
Yeah.
Okay. And then you go over here and you put the Y piece of the first point, you put the Y piece of the second point. Yeah.
So L1 is the X piece, then the
Yeah,
L2.
this is like X, Y table. X, Y.
Oh, okay.
Don't worry about these other things.
Thank you.
If I want more data.
Yeah.
Lots of data. All right, guys. Anything else from homework stuff? Okay. All right. I'm only missing 9 people now. So, okay. Deal with that. All right. So I promised you that tonight we would focus on logarithmic functions. So that's exactly what we're going to do. If you already know some stuff about logarithms, just put it out your head. Let's approach this fresh. So the first thing I want to do before we even talk about logarithms themselves, we're going to graph a logarithm before we know what they are. Does that sound exciting? All right, let's see. Let me turn off the Death Star. Bam. So how am I going to do that? So what a logarithm fundamentally is it's an inverse of an exponential, right? Same way that the cube root is an inverse of a cube. Same one. Which is great. That's why we're going to be able to graph it before we even know what the function is, because I can graph an exponential function, right? So let's start. What do you guys want to use as the base? Anybody? Don't choose 11 or something crazy. No, nobody has anything. Nobody?
5.
5. Okay. So can you take a minute? I think the only pen that's working at the moment is my red pen. So there we go. Oh, where are you going? Can you take a moment and try to graph y equals 5 to the x? You can make a little table if you want to. I would always use those for sure. All right, let's see. I'm going to catch up to you guys. 5 to the -1 is 1/5. 5 to the 0 is 1, and 5 to the first is 5. So -1, it's at 1/5. At 0, it's at 1. At 1, it's at 5. Sure. And it's got an asymptote right there. And this is our first example of a one-sided asymptote. Do you see what I mean by that? It's only approaching it from when it's going this way. That it never approaches that. It's just down here. All right. How do I plot the inverse? Do you guys remember? How do I plot the inverse?
Is it flipped over the x-axis?
No. How do I find the inverse? What do I do? Algebraically, how do I find the inverse? I take the what, and then I what them?
You switch the values,
Switch the
x and the y.
x and y. Okay, so let me just do that. Let me switch the x and y. So 1/5. Do you guys remember doing this? No? Yeah. So now 1/5 is -1. 1 is 0. And 5 is 1. Now somebody please tell me. Now watch. Where does that asymptote go? Right now, this is the asymptote y equals 0.
Why, then it would be the x.
Yeah, now it's going to be x equals 0. There's an asymptote here. You can see that happening here, right? So it's going to come 1. It's not bad, Jeff. And you see, it does exactly what we thought it should do. Remember the mirror goes right here? So that makes sense. There's that mirror that goes right down the center. What? I can't do it. All right. So we have a graph of the damn thing. This is what they all look like. They all have this shape, and they all have an asymptote here, and then I can shift it like anything, right? I can shift it around. So now that we have a graph, what the hell is the function? So what should its how do I say this? What should its could help me? What should its function be? What should it do? Let me try to get at this. So what does this guy do? When I input a number, it raises 5 to the power. So on this problem, in this problem, it becomes this, and this is not acceptable because I want it solved for y. All right, I really want you guys with me on this. So watch this. I want to show you a little side example. What if I had y equals x cubed? And then I switch it to x equals y cubed. Why can I go one more step? Why can I solve that for y? What do I do?
Cube root.
Cube root. So we have chosen a symbol that means the opposite of cubing. And then we apply that symbol. So all we have to do on here is choose a symbol that means the opposite of 5 to a power. So what do I mean? So for example, what's the cube root of 8?
2.
2. Why is it 2? Because 2 cubed is 8, right? So this is showing why the answer is 2, but it's written like this. I really want you guys with me. So how would I write it without using the cube root symbol? I would say, you could do it, Jeff. 8 is what cubed? Doesn't this and this ask the same question? Do you guys follow what I'm saying? What question does this ask? What does it take 3 of to multiply to be 8? Isn't that the same question this asks? Does everybody get what I just said? Does anyone not get what I just said? So these both ask the same question, but in mathematics, we like to consolidate that question as much as possible. Stay with me. This is so cool. This is so cool. I trust me. You got to understand. Why are roots relatively easy to us? If I say, what's the square root of 16? Does that take a lot of thought? No. Why? Because you know what the square root is. You know the question it's asking. You have put it in yourself. You don't even have to translate. Is anyone learning a second language? Or have you already learned a second language? Anybody? Anybody? Okay, Rio. So when you were first learning, didn't you have to consciously translate? Right? Do you understand what I'm saying? I mean, I certainly had to learn. I actually took Spanish and French and never really got either one of them understood. But I mean, I couldn't just start talking. I'd have to think ahead of time and translate it as I went. Are you guys kind of with me? Math is a foreign language. So we want to come up with a symbol that means something. This means, what does it take 3 of to make this? That's what it means. And we don't even have to translate it, do I? Do you guys have to translate it like that when you look at it? No. Stay with me, stay with me. So we need a symbol that would accomplish this kind of thing. If I said 25 equals 5 to the what? Of course, what would the answer be?
5, the 5th.
No, come on, stop.
Is 2, right? Second.
Yeah, 2. You're thinking about times. Okay. So that answer would be 2. So I want something that the sentence it would stand for is what power does this need to become this? That's what the inverse of an exponential has to be. So here's we already know what symbol we've come up with. I already kind of gave it away when I said it was logarithms. So here's what it looks like. This would be y equals log base 5 of x. Now let me ask you why that kind of makes sense. Isn't 5 the base? 5 is the base. So saying log base 5 makes sense because it's base 5. Now stay with me. Stay with me. So watch this. So the same way that we actually kind of have to try to make this translate in our head before we kind of get used to it. What does it take 2 of to multiply by 16? It takes 2 4s. Okay, that's the answer. Yay. And then we get to a point where we don't have to do that. We just sort of internalize what the symbol means. Well, you're not there yet with this kind of shit. So log base 5 of 25, what do you say to yourself? What power does 5 need on it to become 25? Or how many 5s would multiply to be 25? So of course that answer is 2. So what if I wrote this?
Three.
Good. All right. I like it. For a minute there, I wasn't sure what Austin was doing. But yeah, 3. 3 to the 3rd power equals 27. All right. So we can say log base 3 27 equals 3 because 3 to the 3rd equals 27. So in much the same way that this asks you to think backwards, what does it take 2 of to multiply by 25? 5. This symbol asks you to think backwards. How many of these does it take to make this when I multiply? How many of these do I multiply to get to this?
2.
2. All right. So can somebody tell me, this is going to be a little bit weird of a question, but I'm not sure how else to ask this. Physically, what is the answer to a logarithm always? Physically, what is this? It's a what?
Exponent.
Yes, good. So a logarithm is a power. A logarithm is a power. It's the power that this needs to become this. That's what a logarithm means. Logs are powers. Okay, I like it. Let's try some freakier ones. So it's all about internalizing the question that the symbol represents. And we've done that already with roots. That's why we don't even think twice about them anymore. Logs, we're not quite there yet. So what about, who thinks they have this here? Log base 25 of 5.
1/2.
Yes. Is that cool? All right, now let me try to make a point here. Let me kind of do this methodically. Let's do 8 because 8's not too bad. All right, what's log base 8 of 64?
1/8.
No, you thought I was doing something. I'm not doing that. I'm not doing something like this. This is more straightforward. 8
Right.
to the what power is
2,
64?
right? 2, yes.
2. All right. I know you thought I was going to do something weird. Not yet. What's log base 8 of 8? How many 8s does it take to multiply to be 8? Yeah, 1. Right? 8 to the 1st power is 8, correct? Okay, I like it. What is log base 8 of 2? I like this question a lot also. I love this question.
1/3.
Good. All right, stay with me. This is 1/3 because it's the cube root of 8. Real quick, do I still have it up here? Do you remember this? Log base 2 of 8 was 3. Do you see the relationship here? If it takes 3 2s to make 8, it takes 1/3 of 8 to make 2. I don't know if you guys are with me. Just stay with me. Stay with me. Hold on. I'm trying to make a deal. I don't know if you guys noticed already something happening. What's log base 8 of 1? Here, here's something neat. Something neat.
0.
0. And what is log base 8 of 1/8?
-1.
I like it. Does anyone not understand where any of these came from? Please speak now. Or speak later. Speak sometime, please. Everybody's with all of this. Everybody's with all of this? Now notice, here's the point I'm trying to make. If it's the base or above, if the number in here is the base or above, it's 1 and up. If the number inside is between 1 and the base, you'll get a fractional answer. Because that would be a root. It would be cutting it down in size. That would be taking a root of it. If the inside's a 1, that's 0. So of course, if the inside is below 1, if the inside is some fractional thing or some number between 0 and 1, your result's going to be a negative number because now it's got to flip it. Now it's got to make it a fractional thing. That's a kind of a cool, I like that. Maybe it's just me. I don't know. Or maybe these are too new. You're not really sure what I'm trying to show. I don't know. So, because it always gets people tripped up somewhere. They're like, when is the answer a negative and when's the answer a fraction? It all depends. If this number is between the base and 1, then this is going to have to be a fraction. It's going to be a root. If it's less than 1, if it's a fraction, it's got to be a negative number. It's got to be flipping it somehow. All right. Now, obviously, hopefully you guys don't think this is too hard because this is easy. This is the easy stuff. It's going to get harder. All right. Let's see what else can I do. Here we go. Yeah. All right. You guys got all this? I'm going to take this away. Maybe I should. Yeah. Let me stop for a minute. I want to show you. There's a handout up on the website. Can you go to Canvas right now? There's a handout up there. Let me make sure that I made it active. No, you don't. It is okay. Let's see. Let me show you guys where it is. Oh crap! Wait a minute. Stop. There we go. Where is it? There. So if you go to modules, you make this student view. Student view. Do it. Go to unit 6. Whoops, I went too far. Unit 6, basics of logs. I like it. So this is quite a bit of reading, but it's still, I mean, if you need to remind yourself, it's basically captures what I just said, my lecture from talking about roots and what they mean. And then we slowly develop this lot. I actually tell you that where the etymology of the word logarithm, if you were interested at all, you're like, oh, great. I can answer that Jeopardy question now. So what I want you to do real quick is try to do these problems down here. See what you can do with these. Yeah, so go to Canvas, access that. Here, let me put it up on the screen in a better way. Hold on. Yeah, here we go. Get up there. Oops, this one. All right. So I want you to do these problems right there for me. I'll just sit here and wait. Oops, I don't want to do that. Let's see. All right. These first four, you should be done with if you understand the idea. The next four get a little bit freakier, especially the last one, maybe. I don't know. We'll see. What did you guys get for part A here?
4,
Yeah. Why?
because 3 to the 4 power is 81.
Kick ass. I need 4 3s to multiply to be 81. Done. Logs are no big deal. They are powers. They are what power do you need to make the base the thing on the inside. So, of course, what's part B? It's even easier.
It's 2.
Say again, sorry.
It's 2.
2. I love it because they just need 2 4s to multiply to make 16, or 4 to the second power is 16. Kick ass. What about C?
0.
Kick ass. Anything to the 0 power is 1 except 0. 0 to the 0 is, let's not talk about him. He's some freaky shit. All right. And D is easy too. What's the answer for D?
4.
4. I love it. All right. You must let me know somehow, sometime, if you had any trouble with any of those 4. That is purely right off the idea. Now, E is also, but for some reason, E gives people trouble, but E is almost too easy that you make it harder than it is. Who thinks they have the
Just
answer?
8.
Say again?
Is it just 8?
It's just 8. It's insane. It says, okay, what power do you need to put on B to make B to the 8th? Do you see how it told us the answer? And then here's something even better. What is the fundamental relationship between a logarithm and its associated exponential? So what's the relationship between log base B and B to a power? What is the relationship? What did we do? You could do it. What kind of functions are they? How do they interact? You can do it.
Exponentially.
No.
Oh,
How did I graph the logarithm? Because I found the inverse. Exactly, Amanda. So look at another way you can look at this problem. This is making this problem, I don't know. Here's another way you can look at this problem. Dadgummit, Jeff, I can't remember how to use technology. Okay, here we go. I can say log base B and B cancel. So you're left with 8. Done. Another, let me do a little E part 2. Watch this. This is really neat. What if I had 7 to the log base 7 of W? Okay, that sounds like a horrifically ugly problem, but based on what I just did, what would the answer to this be? 7 to the log base 7. What do these two things do? What did these two things do?
Kill each other.
Yeah, they kill each other. So the answer is W. Done. Next. It's exactly like cubing a cube root. You're applying a function. You're applying an inverse to the function. So of course they kill each other. Now, real quick, I'm sorry. Whenever I do this problem, I can't help myself. I have to say this. Let me write this again because I've really screwed this thing up. I really want this to make sense. All right. What does this represent by itself? What's a logarithm? What's a logarithm fundamentally?
The inverse of an exponent.
I like it. Now, even more fundamentally than that, the answer to a log represents the what? You can do it. I try to make a big deal out of it. A log is a power. A log is a power. A log is a power. Did you hear that a log is a power? Did you hear that? Log is a power. So it's the power that the base needs to become this, right? Why is it 4? Because 3 needs a power of 4 to become 81, right? So now watch this. if this is the power that 7 needs on it to become W, what do I get when I raise 7 to it? I get frickin' W. I don't know if anybody understands what I just said. Very few ever do. And it's just such a beautiful thing. So what does this represent? Somebody tell me. This is the power that does what? What does this power do? It's the power that what needs to become what? You could do, come on.
That 5 needs
To become
A.
A.
Or
It's the power.
Whatever. Yeah.
Yeah, right up here. For example, why was the answer 2? Because what power does 4 need to become 16? 2. So this represents the power that 5 would need on it to become A. So what do I get when I put that as a power on 5? I get frickin' A because that's his job. It's what it does. But what's the slightly better way to look at it, I guess? These two kill each other and you're left with A, right? All right, I'll stop. I like the other way to look at it, but that's just weird ass me. All right, let me get this out of here. Go away. You're scaring my kids. Go away. Now, what about the rest of these? What about part F? That shouldn't be too bad, right? Part F?
-1.
Negative.
Yeah, you say to yourself, what do I do to 5 to make it become 1/5? I got to flip it, and a negative power does that. I like it. Here, let me do F part 2. Why not? What would this be? Log base 5 of 1/25.
-2.
Yeah, you got it. I think you got it. You got cut off a little bit. -2, because not only do I have to flip it, I also have to square it to make it become 25. So -2. Okay, I like it. I like it a lot. So what happens on G now that I've done that? What's G going to be?
-2.
-2. Holy shit. Because I got to flip it and square it. So -2. All right, who thinks they have this guy?
2/3.
Beautiful. So you have to rewrite m to the m squared cube root. Let me try to say this again. Cube root of m squared. How do I rewrite that? Root on the bottom, because that's where roots are. Power on the top. These kill each other. 2/3. Done. Sorry. All right. Now, let me see. What else did I want to do? I mean, did anyone come into this? Who's seen logs before? Anybody seen logs before? Work with them? Do you guys remember? Anybody? Anybody else? All right. So Jordan, that's it. David has. Okay. And then maybe some more people in chat. Yes, me. Okay. Does this, I'm sorry. Oh, everybody's good? Okay. Does this jive with what you've been told before? I mean, does this sound familiar? Did this help at all if you hated logarithms before? I mean, is this, no? You're like, not yet, Jeff, keep trying. Yes? Okay. You don't have to say yes just to butter me up, right? Don't do that. You can tell me, no, you're doing shit. It's not good. Okay. So the most important thing, and I think the thing that a lot of teachers miss or forget, I love making the connection with the square root symbol. Oh, let me see. Oh, yeah. We're going to do that in a minute, Bowen. We're going to do that kind of thing here in a minute. Because when we get really weird shit, we're going to need some help. You got it. Yeah, exactly. Sorry. What was I saying? The square root symbol itself was a symbol we had to pick. Somebody in history had to decide that that was the symbol that meant, and again, you know how I feel about it. I wish they wouldn't have come up with it. But even like exponents, even like the squared, at some point, somebody had to decide, if I put a 2 right here, it means I'm multiplying that many of these, right? And this is something we don't think a lot of as students, especially. You don't sit and think, all of these were choices we had to make, and then we had to communicate to everybody else, this is how you read my weird ass way of doing this, right? All right, I don't. So logarithm is a really poor choice. I will agree. It's not a great idea to use something, especially when it is a word that means something already, right? So we don't look at this as a function, not the same way you look at square root of 9. That's a function. We know it's a function, and we know what it does. We don't look at this like a function. So I think that contributes to the weirdness. Is you're like, this has got to be completely different. No, it's just a poor choice of symbol. It really is. But as long as you know what it's asking. So this is like the early stages of learning a different language. You have to stop and remind you, okay, you're going to try to translate a sentence. You got to go, this means this, this means this, this means this, and then you can read the sentence, right? Now it looks like I just like, anyway, genuflecting. So you have to do that with this. You have to go, what does log mean? It wants this. Okay, and then I have to figure out what it needs, and there it is. Okay. All right, maybe. So let me show you this other. I don't think I put this up here yet, did I? Hold on. I do have one more log thing I want to show you. Did I put it up here? Where are you? Hold on. I don't think I put it up here yet. So let me throw this up here. Where are you? There you are. Okay. Well, let me just throw it up here on the screen, and then I'll put it up there later. Okay, here we go. Oh, not that one. I don't want that yet. Shit, where'd the other one go? Sorry, guys. We're doing it live here. We're doing it live. Oh, okay. So let's talk about. Okay, so let's do a couple things. Let me do it up on the board. That's easier. I don't have the handout right here. Where'd I go? All right, let me see. Okay. So let's look at graphing these things a little bit. So let me ask you this. All right. We're not going to do too much more, to be honest. We're going to leave a little bit early tonight, but I want to do a little bit. Can somebody remind me? So recall, this is old news, old news. How do you find the domain of this?
You don't let it equal 0.
More than that.
You can include a 0.
What? Wait. Come on, guys. I say x minus 2. The inside has to be
Greater or equal to?
yes. Okay, good. And then I solve it. So add 2. So x has to be greater or equal to 2. Now, logarithms, they look like this. If they haven't been shifted, they look like this. Right? That's what we just learned earlier. Exponentials look like this. Logarithms look like their mirror image. Right? What is that? What is it? So what if, let's say that this is log base 5 of x. It doesn't really matter. What is this guy's domain? What's his domain?
Greater than 0.
Good. So 0 not included to infinity. So a logarithm has a lot of similarities to a radical. They're similar, but they're definitely not the same thing. So for one thing, this is allowed to equal 0. The inside of a logarithm is not allowed to equal 0. So how would I find the domain of this? What would be the difference? I would say the inside has to be strictly greater than. It can't be equal to 0. So in this case, it would be strictly greater than 2 instead of at least 2. All right, good. I like it. So I just want to throw that at you real quick. And now I want to step back, and this is what I really want to do. So that's just something to kind of keep in the background. We always want to know how to figure out the domain of any new function we create. That's a new function. That's how I figure out its domain. Very similar to radicals. Now, Let's talk about this. Oh shit, somebody left. Do you remember how I rewrote this to see why it made sense? How do I rewrite this? Why is this true? Because what? Do you guys remember? Because
2 cubed.
yes, so I can always rewrite a logarithm in exponential form. 2 to the third power equals 8. And of course, I could do it vice versa. I can do it the other way around. So if I give you a logarithm, let's say log base W of A equals P. How would I rewrite that in exponential form?
W to the P.
This is, let me, just in case I totally made these letters up out of nowhere. Just make that an M for me so it doesn't look like something else. Okay. I don't know if nobody got that obviously. So you guys, that's fine. So W to the
M is A.
A. I like it. Okay, I like it. No worries, right? Now, can you go the other way around? What if I give you something that's exponential, like 7 to the C equals X? How would I write that as a logarithm? This is a little bit harder, but what's the base?
7.
7. What's the power?
C.
So that, and why does this make sense? The output becomes the input because they're inverse functions, right? So the output becomes the input, the base goes here, and the input becomes the output. The power is what a log is equal to. How do you check yourself? 7 to the C equals X. It's easier to go from log to power than to go from power to log. But you can always check yourself at the end. Check yourself. All right. So last thing for today. I think I made it sound like we were going to be done even earlier, but too bad. How do I do this? Let's see. Let's get something really freaky up here. Log base 27 of 9. Doesn't this feel like it should have a relatively not easy answer, but there should be a definite decent answer to this?
Negative 3.
No, I appreciate the attempt.
2/3.
Maybe. Let's see. But maybe let's find out. So one way to do this problem is to say, I don't know what the answer is. So let me call it X. All right, now watch this. Can you rewrite this now? How would you rewrite this into exponential form?
27 to X power 9.
What do these have in common?
Base 3.
Base 3. So how would I rewrite 27? It would be 3. Let me get rid of that. Hopefully you guys are cool. 27 is 3 to the third to the X. So I would multiply power. So it's 3 to the 3X. And what's 9?
3 squared.
Squared. Now, let me stop for a minute. So all I did was I took this funky ass log, I rewrote it in exponential form, and I know this is going to work because these are both based on 3. What must be true about 3x and 2 in order for this equality to be true? 3 to this equals 3 to that. What's the only way they can be equal?
3x equals 2.
Yes. And then we finally catch up with x is 2/3. Now you ready? Here's the ultimate shortcut for this. Watch. This is so cool. All right, this is the absolute last thing. I'm sorry. 27 is 3 times 3 times 3, right? How many of those does it take to make 9?
2 of those.
So 2/3. Done. 2/3 of 27 multiplicatively is 9. That's why the answer is 2/3. Yes. And that might be what the person who said 2/3 earlier noticed. So I appreciate that. That's awesome. All right. That's enough. That's enough. When can you do this? You can do this anytime, to be honest. You could even do this on an easier problem, right? Somebody was pointing that out to me in the chat, but this is definitely the problem that I would tell students you might want to do it on. I can't point to it because I don't, there we go. I can't think like that on my brain. That kind of problem, rewriting it makes it easier to think about. And you base it on the same base, you can do it. All right, guys, that's enough. Let me know if you need to hang out afterwards, if you have a question.
Yes, I have a question.
Yes.
It's same thing on the calculator earlier. So I put the values. Then how do you determine the function?
All right, hold on. Let me move you over here. All right, so I'm just going to put stuff in. All right, so you got those in. You got numbers in there, right? Uh-oh, we got a chat. See you, Dave. Stat. I want to calculate. And you got to go to, you can get to exponential. I want to calculate an exponential. This REG means regression, but that's a statistical term. So I just want to calculate an exponential model. So I just picked the X reg. X list is L1, Y list is L2. Don't worry about the other stuff. Calculate. Now, of course, you're not getting the same answer because I just put other points in there. But did yours come up with an answer? You want me to do it again? You doing okay? What's up? Rio, are you okay?
After I type press the 0.
Yeah.
That one. It doesn't show the X list or anything.
Oh, you're okay. You got a, all right, so you got an older calculator. So let me change to classic. Let me see if this does. I think this should do it. So let me see if this does the same thing for you. No, shit. I don't know what to do. So the older calculator, does it just come up with X reg?
Yeah.
Just hit enter. It defaults to list 1, list 2.
Okay.
You're not going to get the same numbers because I put different points.
Oh, so I only get the A and the B, I guess.
Yeah. Do you see A and B?
Yes.
And it's
okay. Now I got it. Thanks.
Okay.
Yeah.
I just put different numbers in there because I didn't remember what.
Thank you.
Points. You're welcome. How's everybody else?
Have a good night.
See you, Austin.
Hey, good night.
Take care, man.
I have a question for what's it called? Section 5.6 on question 51.
Let's see, 5, 6. Okay. 51?
Yeah. I found the numerator and denominator, but still, when I tried graphing it, like it didn't match with the like intercepts.
All right, so let me see. So here's what you got to do. This is kind of neat. So what'd you get for the numerator denominator? What'd you get?
All right, so the numerator, I got x minus 2. Oh wait, no, x squared minus x minus 2, and then.
Oh, I see. So you
the
already, so you started with, let me catch up to you. X minus 2 and x plus 1, right?
Yeah.
Okay. On the bottom, you got?
The bottom, I got x plus 5 and x minus 5.
Okay, good. I like it. And then you multiply those out. So here's the thing. So that's y equals this, right? So when you plug a 0 into x, all the x's, right? Then the output better be 4. So you put a little a here because you don't know what the front's got to be. You don't know what this multiplier is going to be. So now you just plug a 0 in for x, and then you just work it out. So you make that come out to be 4. Right? So you put a 4 there equals a times, and you're going to get a number here once you plug a 0 in, and now you just solve for a. I always like if you pick the letter A for that because it sounds like adjustment. It's like A for adjustment. It's the adjustment number to make the intercept work correctly.
All right. All right. All right. Thank you.
Kind of thing happened earlier in the book somewhere. I can't remember where it was, but whoa, I gotta get it. Haircut. All right, sweet. Anything else, guys?
No, thank you.
Okay.
Have a good night.
Take care, Lars. What's up, Faye?
I'm still stuck on 63 from when I asked earlier for solving it.
Which section were we on?
5.7.
All right, 63. Oh, all right. Yeah, this is not going to be like easy, but I'm pretty sure we looked at this in class and I got up to a certain point. So let me see. So A equals 2 pi r squared plus 8 pi r, right? So I would take 2 pi out, leave some room, complete the square, right?
Okay. I think that's where I got stuck because I think I was trying to complete it. I was like, how do I apply completing the square to this? But okay.
Yeah, so you got to make a 1, so you get rid of the 2 pi, so you take it out. And then it's just, half of 4 is 2 squared is 4. But then what do you have to subtract now to balance it back out?
The 8? 8?
No, 8. Right now I added 8 pi. Do you see that?
Yes, 8 pi.
So I better subtract 8 pi at the same time. So now you've got A equals 2 pi times r plus 2 squared minus 8 pi. So now you can add 8 pi and divide by 2 pi and take a square root. So now you can start to solve for r.
Okay.
Yeah.
That's a little much better. All right. I think I can go from there now.
Cool.
All right. Thank you, Professor. Have a good
No
night.
worries. I'll see you.
Yeah.